everyone, my name is Dr. Valerie Meyer-Spiridolozzi, and I teach Industrial and Systems Engineering here at the University of Rhode Island. The Yukon URI Navy STEM Coalition works with the National Institute for Undersea Vehicle Technology and many of our partners throughout the region who build submarines and support our defense industries. Come take a look at what we're doing.
Hello, young scientists and engineers. My name is Sean, and I'm an electrical engineer at the University of Rhode Island. Welcome to the Power Electronics Lab. We've heard you've been conducting some investigations around electric energy transfer in your science class. So what are some things you use every day that are powered by electronics? As electrical engineers, we design systems and equipment that use electric power. So it sounds like we're working on similar things. Come on into the lab and let me show you what we're working on.
So here's our system. Do you notice any components in the system that are similar to what's in your system? Notice the battery in the system. What's that typically used for? Notice the wires in the rest of the circuit. And here is a switch. What happens when I close the switch? What proof is there that energy is being transferred in the circuit? So there's 4 channels in this circuit, and each one of the channels has a switch. You can close each channel individually with each switch. So this channel, this draws 1 unit of current. This channel draws 2 units of current. So with both of these channels, how many units of current are being drawn? Have you ever noticed when you're using, say, an iPad, and you open up a lot of applications on the iPad and you use it for a long period of time? Have you ever noticed that the iPad gets very warm? So why is that? It's getting very warm because you're drawing more energy from the iPad, and its power source is the battery. So when you open up more applications, it's using more power from the battery, and the battery is heating up because it's doing more work. With our system, we're trying to figure out how much energy we can safely draw from a battery. We would measure the temperature of the battery, and each of these channels draws a certain amount of power from the battery. So you could say this is 1 unit of power, this is 2 units of power, these two together would be 3 units of power, this would be 4, and just different combinations of power that we can draw from the battery. That's what these 4 channels are for. What we're trying to do here is see how much power we can draw from the battery and measure the temperature of the battery and figure out the point at which the power being drawn from the battery is causing too much of a temperature rise in the battery. So we want to figure out the point of how much power we can draw from the battery and still have the temperature be low enough to safely use the battery.
So if you're interested in working with electric systems, you should consider becoming an electrical engineer. Maybe I'll see you on campus someday. Bye.